Welcome to Statistics, Chapter 1, Lesson 2. Today we're looking at measures of variation, namely standard deviation and range. So example 1, Toby Titus is trying to sell some of his old comic books so he can buy a car. Here are the prices that he saw on BidBay, and here are a list of prices. You may notice that we replaced one of his books so that our mean ends up being a good measure of center here. We are going to be asked to find the range and the standard deviation of Toby's comics, add and subtract the standard deviation to the mean so that we can find the range of a expected or typical comic book price for him. So we're going to look a little bit at using the calculator to help show some of our work when we are asked to find the standard deviation by hand. We'll only have a little bit where we're asked to find it by hand, but this one is going to take a few extra minutes here, even with the calculator. So, things that we need to know. We need to find the standard deviation and the range, so adding to my notes here before I start, the range is always the maximum value minus the minimum value. The highest minus the lowest. We can find those relatively quickly. The standard deviation is a little bit of a process. First, we need to take every single individual x value that we've got. We need to take every data point that we have. We need to subtract the mean. We need to take those results and square them. And then we need to divide by the number of data points we have minus 1. Oh, sorry, I left a piece out here. Before we divide, we need to add all of those together, find the sum, that's capital sigma. And part of why we squared it earlier was so that we have only positive numbers, and then so that when we take the square root at the very end, we will only get a positive number for our standard deviation as well. So this is going to be a way of looking at how to show the work of finding that by hand, even though we are going to use the calculator to get all of the information that we need. So part A, just find the range and the standard deviation. Let's do the range first. So stat edit. I've already put in all of our values here to speed this up a little bit. So stat calc 1 on L1. Our maximum value was $9.10. Our minimum value was $5.99. So 910 minus 5.99 gives us a range of $3.11. So between our biggest value and our smallest value, there's only a range of 3.1 or $3.11. Again, the standard deviation for this sample, S sub x. So first we need all of our data values, each x value. And again, I'm going to use my straight edge here. So just copying that list, 615, 903, 875, 599, 708, $9.10, and $8.65. So first off, this tells us that the number of data points that we have is 8. That's going to go into the equation up here. We have each of our individual x values, x sub I. We need to find the mean as well. So the mean, stat calc 1, is 7.875. Oops, sorry, 7.875. There we go. We will keep everything rounded to 3 decimal places while we're working here, and then we will round to 2 decimal places at the very end because we are dealing with money in the context of this word problem. But in general, whenever you have to round to 3 decimal places in this class. There are a couple of other special situations where we will round to 4, but we'll get to those in a minute, or in a few weeks. So working from the inside out, every individual x value minus our mean. X minus x bar. So going back to our list, stat edit, we can now define a whole list, go up to L2 and hit enter. Second one, take everything from L1 and subtract our 7.875. And now we have all of those values to copy into our chart. Negative 1.725, 1.155, 0.875, negative 1.885, 1.225, 0.775, and 0.375. Again, working from the inside out. Up here, we need to now square everything. So take each of those and square them. And technically, these are all of our individual x's. You can leave the I on or off as you need. So again, go up to L3 now. We're going to take everything in L2 and square it. And then copy those. Now I'm copying to 3 decimal places while I'm working. 2.976, 1.334, 0.766, 3.553, 0.632, 1.501, and 0.601. So now we need to add all of those together. That's what this sum symbol means, the capital sigma. But again, that capital sigma of all of our x's can be found rather quickly by running a one variable stat on L3. And that way we don't have to worry about the rounding as well. So our sum, the second sum of x, sigma x, is 11.5024. So it looks like we actually only went 4 decimal places in general for that. So now we have all of this top part. We have n, we can subtract 1 from it and take a square root. In order to find our standard deviation is going to be the square root of 11.5024 over 8 minus 1, or the square root of 11.5024 over 7, or 1.282. Or, since we are dealing with money, our standard deviation will vary by about $1.29. Again, we can check that with the calculator by running on our original list, stat calc 1 on L1. Our mean was $7.875, $7.88, and our standard deviation for this sample here is 1.282, just like we had before. So our standard deviation is about $1.29, and that takes care of the rest of Part A. Part B, we just wanted to find what the most typical price was. So our mean, since we are now dealing with the money part of this, let's call that $7.89. Our standard deviation is about $1.29. So if we take our mean plus one standard deviation, and then we'll take our mean minus one standard deviation, we're going to have 789 plus 129. We're also going to have 789 minus 129. So our most typical prices are going to be between, at a high end, about $9.18, and at our low end, at about $6.60. So Toby's typical prices for comics are between $6.60 and $9.18.